Hi everyone, I welcome you to this lesson on integration by parts. In this lesson, we are going to learn this method, although this method is not a part of mathematical methods curriculum, but it is a very important added skill that can help you cross-check your answers. Integration or anti-differentiation is used to undo the differentiation. So integration by part undo the product rule. So let's write down the product rule. So according to product rule, if y is equal to u times v, then dy over dx will be equal to, first we differentiate the u, keep the v as it is, and then we keep the u as it is and differentiate the v. After doing that, to understand the integration by parts, we need to do is we need to multiply the entire equation by dx because dx is common denominator in all of them. So we can multiply by dx. So on multiplying by dx, we'll get dy is equal to v times du. After that, we use the trick of integrating both sides. After that, we can write y will be equal to integral of v times du plus integral of u times dv. After that, we can write the two formulae. So sometimes you may have to find u times dv. And to find that, we need to move this integral to the left-hand side. So that means that can be written as, and sometimes you may have to find v times du, and that can also be written as y minus and these are two little formulae to, be used in the integration by parts. So in the next examples, I'll be using one of them and I'll show you how to use them. In this question, we need to find the integration of x times cos x. So we need to first of all find that what should we write as something times something so that we can successfully evaluate this integration. So in order to do that, we'll say, let's say u and v, and I want to find out x, and then I want to see dv to be cos x. So if I can multiply these two, so that means I'll get x times cos x. So let's fix that this is a good situation. And the cos x is the differentiation of sin x. So therefore, v must be sin x. Now du will be, so the differentiation of x will be 1. All right, so we are now set to use the integration by parts. As we have learned that the integral of u times dv will be equal to y minus integral of v times du. So y we had assumed as x times sin x. So these two multiplied together will be your y. So x times sine x minus integral of dv times du. Now dv times du will be these two. So that will be sine x dx. The integration of sine x will be minus cos x. And then we need to introduce a constant c because it is indefinite integral. And this is the answer to this problem. Now to check that it is correct, we can use a CAS calculator. So in our CAS calculator, we need to enter our function. And we are getting the correct answer. Now we are going to do the next problem. Let's see how it looks like. We can say that u and v, so these are two things we need. So the first one is the u and then the v. And in the u, we can choose x, but we need dv to be e to the power of x. So that when we multiply these two, we can find the integral of x times e to the power of x. And the du will become 1 because the differentiation of x will be 1. And the integration of e to the power of x will be e to the power of x. And also differentiation of e to the power of x will be e to the power of x. So v will be e to the power of x. Therefore, y will be equal to u multiplied by v, or x times e to the power of x. Now, if we were to find the integration of u times dv, so that will be equal to y minus integration of u times du, v times du. And that will be x times e to the power of x minus 1 times e to the power of x integration. And that should be, and that's the answer to this problem. Now to check if this is correct, we need to use our CAS calculator to enter a function e to the power of x. And the answer is x minus 1 bracket times e to the power of x. So this is correct. Right, let's move to the next problem. In this problem, we have to integrate by parts e to the power of x sine x dx. Sometimes we may have to use the integration by parts 2 times. All right, so let's say our y is u times v and u and v. Yeah. Now u is e to the power of x, and dv should be such that we get sine of x. The differentiation of sine of x is only possible if we have minus cos of x at the top. Yeah. And the du will be e to the power of x. So the differentiation of u will be e to the power of x. So we can see that our aim is to find e to the power of x sine x integral. So therefore we can say that integration of u times dv will be equal to y minus integration of v times du. And that will be equal to y in this case is u times v, which is e to the power of x times minus cos of x. And integration of v times du will be e to the power of x times minus cos of x dx, which makes it and that's our first conclusion. That is our integral e to the power of x sine x dx. And let's say this is also equal to I. So our value of I is this. Now the problem is that we need to find this integral. To find this integral, we need to use our integration by parts second time. So for the second time, we will once again have to, so let's say this is u, v again, e to the power of x. This time we want cos x here. So in order to have cos x, we need to have sin x at the top because the differentiation of sin x will be cos x. So we are trying to find e to the power of x times cos x, and which is this one here. And let's say give it name I1. So therefore our I will be equal to minus e to the power of x and this will be y minus, so y in this case will be e to the power of x times sine x. So these two multiplied together. So e to the power of x sine x minus integral of e to the power of x sine x dx. So this will be the value of I1. Now what we need to do is, this is our also I, because this is our integral I. So this is I. So what we can do is we can move this I to the left hand side. So we get 2I equals minus e to the power of x cos x. Now we can write that 2I will be equal to e to the power of x taken common. So I should be equal to and that is the answer to this problem. So integration by parts is undoing the differentiation, the help of product rule. So the product rule differentiation, so integration by part undo the differentiation product rule. So integration by parts, let's do another example. This time we have to evaluate this integral. This time we have to evaluate the integral, I'm sorry. So in order to evaluate this integral, we have to first find what is the integration, and then we need to evaluate this definite integral. So let's say y is equal to u times v. And we know that the differentiation of e to the power minus x will be e to the power of minus x. Minus times e to that minus is because of the chain rule. So because the chain rule, the differentiation of minus x will be minus 1. So minus 1 times e to the power minus x will be minus e to the power of minus x. Differentiation of x will be 1. So now we want to find the integral of this. If we move this minus up, so it will make our life a little easier because the differentiation of minus e to the power minus x will be e to the power of minus x. Now we can write our formula. So according to our formula, the integral of u times dv, this is dv, u times dv will be equal to y, and that has to be evaluated from 0 to 4 minus integral of v times du. And that also has to be evaluated from there to there. So y in this case is x times minus e to the power minus x, so minus x times e to the power minus x. That's our y value. So y value is always u times v, which is this one here. And then minus, you have v times du, and v times du is minus e to the power of minus times minus will be plus, and we can substitute the values and evaluate these definite integrals. So minus taken outside. And the integration of e to the power minus x will be e to the power of minus x divided by minus 1. The chances of plus minus mistakes are very high. So practice, practice. That's the only way. I move this minus 1 to the outside like this. And then after that, I have substituted my values. Always follow the best. The best method is that you always move the coefficient outside, and then after that you substitute the values. Otherwise, you'll be making heaps of trouble for yourself or maybe mistakes. So it's minus e to the power minus 4 plus e to the power 0 is 1, so that's plus 1. And that makes it minus 5 e to the power of minus 4 plus 1, and that is your answer. Or you can write in, and that's the answer to this problem. I think that is all for today, and I'll see you in the next lesson. Thank you very much for joining. Bye.